If we can reduce the material that we throw and we have a kind of cheap and clean material that shields the expensive and critical components like batteries or switches, then we can have a nice opportunity to reduce a lot of waste.
Our guest today is Dr. Axel Boese. Axel is an expert in medical innovation and sustainable medical device design. He has been working at the intersection of technology and healthcare, focusing on how to rethink medical products for efficiency and environmental impact. One of his key areas of expertise is hybrid use medical devices, a concept where durable components like electronics are combined with single-use disposables to reduce waste, cut emissions, and still maintain patient safety. Here's our discussion. Hi, Axel, and welcome to the podcast.
I'm honored to be here in the podcast with you. Thank you.
Okay, so Axel, you're an expert for medical innovation. How did you arrive at the concept of hybrid use devices, and why is it such an important idea for medical technology today?
I have the really nice opportunity to work in parallel in a hospital in an innovation lab, and as an engineer, I'm allowed to join a lot of surgeries and medical procedures. And when you are in such a close contact to the procedures or processes in a hospital, you see this huge amount of waste of single-use product that we produce every day. And this is more or less what somehow makes me a little bit shivering when I see this big waste that is really, really dramatically, and also it's getting more and more. And I think we have to rethink our processes and our use of these resources. And what maybe drives me additionally even more is that we now are on this change to a digital hospital. So we expect a lot of devices that will have batteries, that will have drives and motors and displays and any kind of electronics inside. And a lot of these devices will be waste. And if we have to throw all these really toxic, but also maybe nice and expensive materials, this is, really, really sad. And I think we have to change something, and hybrid use is, in my opinion, a good solution for that.
Okay. So to untangle that a bit. So number one is you're working in a hospital and in innovation. So that's a very unique position. And you're noticing the rising of single-use products and therefore a lot of medical waste. Secondly, this waste gets more and more, let's say, complicated and more connected and electronic. So there is a lot of electronic waste in there. And in order to basically, to put it in a simple term, not throw away the drilling machine after you use it once, or the stapler that you used once, which you wouldn't do in a home setting. You basically go ahead and separate the two components so that you have to throw away the least amount of material. Is that right?
Right. So it's more or less a very old concept. So if you think on all these drapes that you usually have in for example, ultrasound or sometimes even in the robotic systems, you put a plastic drape over it. No one would have the idea to throw a robot. Yeah. So what you put to keep the sterility in the OR, you put a drape over it to separate the unsterile and the sterile part. And more or less now we translate this concept for, let's say, other devices that are maybe smaller, but and maybe less expensive, but still worth to keep them. Yeah. And there's, for example, these staplers is a really good example. Everything that is in patient contact has contact with blood and tissue, and it's contaminated, and you have to throw it. Or you have to clean it in a really, really hard procedure. Yeah. And no one honestly wants to do that anymore. No one will sit there in the sterilization unit with a brush and clean these devices. So that's why these devices are more and more single-use devices. But if we can reduce the material that we throw, and we have a kind of cheap and easy to produce, and maybe also somehow clean material parts that is like a cover and shields more or less the expensive and the really, let's say, critical components like batteries or switches and all this stuff, then we can have a nice opportunity to combine both. So the safety of the single use and the performance of the device with a drive and maybe also with a data connection and data collection.
Okay, so in essence, it's about designing the devices in a smart way so that you don't throw away the very precious components such as the electronics, and that you still can ensure the sterility and, of course, also the convenience of single use. Because maybe one point that we could go a little deeper into is why single use has such a boom currently. And I would say since 2020, 2019, since COVID, why was there a trend? And was it just COVID that did that?
I think, yes, COVID played a really important role in that. So there were these expensive single-use devices already on the market, but really a niche market. And with COVID, they found their way into these in the regular clinical use. For example, endoscopes that you have to put in the patient. So if you have to examine a patient with COVID, no one was sure that you really can clean that. And that's why these single-use endoscopes had a really strong growth and came in use. And in parallel, the hospitals are under a pressure that everything gets more expensive, and the cost spiral is really rotating, especially human resources. And when you look at this on the process of sterilization, there's so much logistics involved. There's also energy, water, and investment involved, that it's really a cost driver in the hospital. And compared to that, now just grabbing into the cupboard and taking out a new clean endoscope that is maybe tenth of the price of a normal standard endoscope that you would buy is quite comfortable, and it's also more, let's say, calculatable. So for the hospitals, so that they can, if you have 20 procedures, you will use 20 endoscopes. There's no repair. There's no sending back, nothing, no cleaning or maybe unsureness if the device is sterile. You just take it and it's like a new device. And this is really something that is nice for the users. And in parallel, it's also nice for the hospital because they can really count and even make some procedures more beneficial. But the waste problem is definitely there.
Yeah. So summarizing, that will be speed and convenience is why they do it. And reprocessing, also you need to have a reprocessing unit. And sometimes you have that and sometimes you do not have that. And then you have to have a quality system. And you have to make sure that everything is clean and safe. And maybe the next question would be is like, how much risk is there if you clean a device and use that again on another patient? Is there like a proof that multi-use devices are less safe than single-use devices?
So not really. So I think there are countries that have a large rate of multi-use. So same as we had maybe decades before. And there's no proof that we do a better job or that the patients are more healthy and or that you avoid infections. It's more like, I think what you have to consider, you have to work in a different workflow. You really have to clean yourself. This is maybe also a big issue that doctors and staff in the OR, for example, are the source of contamination. And if you have multi-use tools that have, for example, like these staplers, they have these like tools that you try to, all these nails that you clamps that you put in the patient, and there are small tiny holes that maybe are hard to clean. You can sterilize that, but it's not clean. So maybe you have inactive tissue there and no one wants that. So that's why it's maybe beneficial to really have these parts that are in direct contact with the patient as a single use. And I totally agree that this can at least reduce effort, maybe not sterility, but effort. And in the combination, so everything that is really, does a good job, but is on the end of the device and it's not maybe deep in the patient, can be multi-use.
Okay, so let's dive a little more into that hybrid use device and which devices are keen to be redesigned in such a way and which maybe are also not for that concept. Could you give us some examples that would work and some that wouldn't?
I would always look on the cost structure and the financial or the cash flow in a hospital. What would be interesting to keep? If you have a syringe, for example, a simple plastic syringe, this is such a low-cost product, and to have any idea of multi-use of that is not worth. It's not, I don't know. So no one will pay for that. But if you have a device where the electronics and the battery and the drives or maybe sensors are much, much more cost intensive, and we talk about devices that such a stapler that costs 500-600 euros, or even vascular catheters where you have 1,300 euros, same to endoscopes. I think this is interesting because then even the waste will cost money because it's toxic waste or complicated waste, and the interest of the hospital on the hospital side should be there to reduce their cost. And if you have this concept of multi-use, you can have a cheap flow of, let's say, covers and sheets and everything that you can more or less put around these more expensive parts. And that's absolutely okay. But in the same way, you can save money because you don't have to buy the batteries always again, and you don't have to buy the drives and everything that is really like, there's also, it's not only material, it's also brain that is inside. It's also like engineering. It's also mounting these devices or manufacturing efforts. And so I think this is the driver. Cost is always the driver, and no one will do it because we think there is a problem. So there have to be a regulation or there have to be a benefit, a financial benefit.
Okay, good. So let's dive a little more into the advantages that such a concept will have. So do you have an idea of how much CO2 emissions you would save, how much cost you would save, how much waste you would save with such a device?
I think CO2 is difficult, so I'm not so in these numbers. But what is clear is that you more or less save more than 3/4 of a device. So this is more or less what you keep, and you only throw 1/4 of the device, and this is a sterile cover. And this sterile cover is a kind of simple device that is maybe injection molded plastic, can even be biodegradable plastic. And you also reduce not only the material on the tool itself, you also reduce transport costs. Because these covers are not that heavy. They have smaller packages. You have less effort in sterilization of these single-use part of these devices. And more or less, you have less waste. So you have to consider all of these numbers and make a calculation. And I think this is quite difficult, but honestly, for me, it's obvious that this has to be done. And especially if we have in mind that these devices will come up more and more, and we want to have this innovation in the hospital, and we want to have the digital devices that collect data. So I think there's no other way than to think on really nice ideas.
Okay. So you would estimate that it's like 75% savings on cost and CO2 footprint and waste. Maybe what you could do in this direction is just take the weight of your components that you have for your prototypes, look up a CO2 footprint at the database, and then you quickly get the CO2 footprint. It's not that difficult. It's probably plus minus 25% on what the actual number is, but it's like the order of magnitude. You will get that right. So I share this estimation because like the electronics usually have a lot of the CO2 footprint in there. And also, if you can make it smart, you do not have a lot of weight that goes into the waste, because like such a cover can be thin and still maintain sterility. Therefore, it's probably could also go into the 80% direction. And it obviously makes sense, but like if you want to really change something, there's always numbers, facts, and data that will at the end give your hospital purchasing the confidence to switch to such a device.
Maybe it's also something that we should consider is that if you switch to a material that you can easily treat as waste. Yeah. So let's say we have a pure plastic, whatever it is, component. You can mill it, you can put it in a bag, you can even sterilize it, and then you maybe can bring it to into recycling. If you have these combined products that have metal parts, that have batteries, that everything, and you put it in a mill, then more or less everything is lost, and the only way to treat it is maybe burn it or dump it somewhere. And we only have one planet.
Yeah. And I mean, on top of that, it's probably also quite a waste. So I had Damien Carr on a few episodes ago, and he said like there's these iridium rings that you use for, I think it was Röntgen, X-ray markers, so that you see where you put your catheter and where the tip of your catheter is. And he said those are single-use devices, so single-use iridium. And that's like one of the most expensive metals on the planet. And it certainly is also in financial terms not the smartest decision to just like throw it in the oven and then leave it where it is. Just one remark, it's not allowed, it's basically not allowed to have like contaminated waste to go to landfill. You have to burn it, or you have to somehow go around and change the waste code. That's the only trick you can play. You can basically sterilize it, then it's not the waste code contaminated waste again, and then you can recycle it.
But honestly, who can make sure that all the waste of the hospital will really be burned or sterilized and then landfilled? So this is a big problem that we see in especially in maybe other countries. I would not maybe count Germany or Central Europe to it, but that they just throw it. Yeah. So in honestly, I have seen rivers where you have a lot of syringes inside, and this is weird. Yeah, we have kids that maybe play around with this stuff. Yeah.
That's not the best idea. I have this pyramid of R principles plus waste management, and it's like everybody talks about recycling. You can do a lot before recycling. You can rethink, reduce, and all that good stuff. But then I always say like, yeah, incineration or energy recovery is not the dumbest thing you can do. The dumbest thing you can do is like uncontrolled landfill or uncontrolled incineration. So like I throw it in the garden and just put it on fire. That's not a good idea. And what's also not a good idea is to throw it in a river. Like, especially if you have like these, I heard an anecdote where they just like put an X-ray machine somewhere, and then you have the radiation source basically that's just somewhere on a landfill, and everybody like in the vicinity gets cancer. So that's not a very wise way of treating your waste. Yeah, but coming back to the design, if you design such a single-use hybrid device, what are the regulatory challenges in getting something like this to market? Because like single-use is also very, very prominent because it's easier to get to the market than a multi-use device.
Yeah, so more or less you also have to consider that you have to test your sterility. So safety and performance is the same if you have a combination product now. And this is like I would say you can handle that like a procedure pack. Yeah, so you have the main device, and as a accessory, you have the sterile cover. There are lots of devices that work like that, where you have that you have a special part that is only allowed to be used with your central medical device. And the regulatory issue is to really to test and to make sure that everything is sterile and the workflow is clear and that there's no handling issue. Just an example, if your handle, for example, with where the battery is inside and the drive is inside, is not sterile, and you have to pack it into a cover, it has to be you have to make sure as a manufacturer that there is a trained workflow in the stuff, that no one will touch that you don't lose the sterility in this whole procedure. So they have a handover procedure. You have how to open a package without contamination, how to put it in without contamination. So that also means that you need a design of the device where you can easily drop, for example, this, let's say, electronic part into the cover. So there should be not something where you have to press or screw or something, because this will definitely kill your sterility.
Okay, so assuring sterility and then training of the staff, that's like the main challenges, as you say. Do you have examples where you have such a device as a prototype and how that worked out and how staff is handling it?
So not even as a prototype, it's a product. So if you look for staplers, there are staplers from a big company where they more or less completely try to run this idea of a hybrid product. You have a battery and a drive system and a control system that is more or less rechargeable, and everything is covered with a polycarbonate housing that is sterile and single use. And this is also important, you can easily take it out after use. You have to consider that you have this polycarbonate housing, and after the use in the OR, there might be blood on the housing, there might be contamination, and then you have to take it out without involving the inner electronic part. And also, therefore, you have to have a workflow. But I think these staplers reduce a lot of waste, and you only have the parts that are in direct contact with the patient that you throw. It's still a kind of waste that you maybe should treat better, because there's stainless steel involved and some joints and wires and some mechanics. That is waste, for example, that you can easily heat up or clean and at least bring it to a recycling. And even the polycarbonate you can maybe put into a sterilization unit and bring it to recycling process again. But it would be nice if you could separate these parts easily. This is not the case now, but at least you can use the electronic unit with the drive and the control, I don't know, up to 200 times.
Okay, good. And do you have an experience on how well they are doing in the market?
I think they have a growing market share because hospitals are aware of it, but it somehow also is connected to what is the surgeon's favorite. And if you are used to a device, it's really difficult to change that. If you have not used the other device and you're trained and you are satisfied with the functionality, and then this waste problem, if you see that every day and you see that over years, maybe you get also used to it, and you don't, when I enter the OR, I have pain when I see this, but I'm not sure if the people in the OR, this is their daily business and it was always like that, or at least in the last 10 years. I think they are somehow used to it, and maybe that's why let's say most of them are not so sensitive in this topic. But I think this is also something that will change, also maybe change with a new generation of surgeons that have a complete different view. And this is at least my hope.
Yeah, I mean, the second thing is that I always see is a surgeon puts his reputation and on the line for a new device. So I take your new device. If your device does not what it's supposed to do, then it's me who has to tell the family that something went wrong. So it's like my reputation and basically the safety of my patients that I'm putting on the line here. And if it doesn't bring me a significant advantage over what I am used to, like the risk of changing is just too big. It's like we do not have to forget that there are people on the line here. And if I'm not really sure if this is really a good thing, and that it works and that it will perform as expected, I am very hesitant to make the change. There's always like the front runners, the early adopters that are really keen on making a change also for ecology. But like the or the biggest part is probably like the mainstream that wants to do the good for the patient, and the waste is just like a necessary evil that we have to take in order to keep our patients safe. What's your take on that?
Yeah, it's absolutely right. But for example, we have both kind of staplers in parallel. Yeah. So, and I always ask myself, okay, why did the surgeon now decide to take this one or the other one? And there's no, I still don't get it. I even asked them and said, yeah, it's the one that I always use. But we have the other one just beside that. Yeah. And we said, okay, but you can use this one. Yeah. Okay. But again, it's also something on the use of the stapler. You also have to be trained. It's not an easy device, and you can do a lot of critical things if you don't train that. And if you have a different vendor or a different type of stapler, you also might have a different way how this device performs, a different pressure that you can use with your hand, or a different, I don't know, you have on these devices maybe 5-6 different switches. You can rotate, you can angle, you can open up and cut, and so a lot of stuff. And this is maybe also something that you don't feel confident to use this. Yeah, a different type, because maybe then you just have one button and you have a complete different use profile. Yeah, you have one button that you press a little, then you press a little bit harder, and this is already 2 functionalities. And so more or less you need a kind of dry run to train that, but no one does it. Yeah, so this is something, then you should have time, and you should have, let's say, kind of test object, where you could just put it maybe in a drape or something, and just to see how it works. Yeah, and honestly, there's no time for that.
Yeah, so that's a great point, usability and ease of use. So devices should also be designed in such a way that it's for lack of better words, idiot-proof, so that everybody can use it and that you can't do anything wrong, because that will help you adopt the device more quickly. Thinking about the example that you told me, the polycarbonate cover for the stapler. I mean, polycarbonate and hot steam have a very, let's say, difficult history. So like the baby bottles used to be out of polycarbonate. It's a very nice transparent bottle, looks very cool, and is also very break secure. So it doesn't break if you let it fall on the floor, which you sometimes do if you haven't slept too well because the baby is crying all night. I know what I'm talking about. And then you steam sterilize it to make it sterile so that the baby doesn't get any bad bacteria. But what the baby gets instead is BPA, because that's the monomer. And it's not as hydrolysis resistant as you would want it to be. And currently the best option in order to decontaminate medical waste is hot steam. So polycarbonate and hot steam, probably not the best choice. So what do you think that in regards of material innovation enabling these concepts? What do you think? Like, do we need new materials, and which properties would you like to have?
I would maybe have 2 different points of view on that. So you're absolutely right with the polycarbonate, but there are other options to sterilize the waste. Yeah, you can use ozone, for example, or you can use microwaves. And that's much, much more energy saving than hot steam. Hot steam is also a waste of energy if you want to sterilize waste. Energy, water, effort, and you only can treat limited amount of waste at one time. So I think now there are a lot of companies working on different procedures. The other thing that you mentioned is it's right. We also have to consider what it does with our waste. So we should not create with the sterilization more dangerous waste than before. Yeah. So this is not the idea. It's maybe not biocontaminated, but it's maybe poison or toxic or whatever. And this is something that is definitely the case. And for all these things that are of a short use time, and maybe are not, let's say, so relevant in use as in the sense of that they have another function than keeping it sterile. Yeah. So keeping it sterile is already a really, really, really important functionality that you have to include. But if you don't have to transfer forces, or you don't have to transfer, I don't know, some light or some information or mechanical motion, where you have critical functionalities that can break, honestly, I would say you can go to the material that is the cheapest, but the cheapest in the whole tournament of the material, or the whole lifetime in the material, yeah, from production to being in the patient, and also being at the end of the chain, maybe in the recycling, or in the at some point of time, all the materials will die, and then you have to treat them in a cheap way. So I think we should consider that. And I would totally agree that there are new materials coming up that are interesting, but the problem is that a lot of these new materials are not certified for medical application, and this is more or less the challenge that we have at the moment.
Okay, good. So what you basically are saying is that the material selection should include the suitability for recycling and design for recycling, so that they can be treated at the end of life also in a cheap way. It's not only like cheap input, but also like during the whole life cycle, and so life cycle cost basically. Then secondly, I have to correct you for something. There's no such thing as certified for medical in terms of a material, because there's always suitable for certain medical applications. So if you have like crutches, you can make them out of basically any material because you have no patient contact. And then you have implants where you have to have all kinds of biocompatibility and change control and whatever measures in order to even get started to being considered as the material of choice. And changing an implant is like, you don't do that. It's just, you just make a new implant and then you take another material. Like switching an implant material only happens if like an earthquake destroys the plant where the implant material has been made, and there's just simply no other option.
That's absolutely right. But we are talking about devices that are in strong contact with the patient. Otherwise, they are not contaminated, and we don't have to change them.
The point is that the materials cannot prove change control, they cannot prove supply security, or they cannot prove biocompatibility. And also like the technical requirements, you cannot forget that, because like many people come to me and say, yeah, but biodegradable would be a great choice. And then I'm like, yeah, but that opens a whole lot of technical difficulties. So material tends to degrade. So inside an injection molding machine, it also tends to degrade. So your material properties go down over time a lot faster than they go down over time with a, let's say, conventional plastic. So it's very difficult to process. Secondly, if you want to steam sterilize or anything like that, they also tend to be hydrolyzed a lot faster. So it's what biodegradation actually is, hydrolyzation. So that's also difficult. So I'm a fan of either recycling plastics, and then, of course, with the safety and quality management and risk management that you have to adhere to, or bio-based conventional plastics, drop-in solutions such as biopolyethylene or stuff like that.
If you even know that you will use a recycling material, you can consider that in your design, and you can maybe make the wall thickness stronger to avoid, I don't know, cuts or breakages or something. But this is a kind of knowledge that you can include, and you can maybe even say, okay, I will force you to only use recycled material in my production line for this product that is where the only function is to keep it sterile. And more or less, there are so many packages where you have to consider that. A package for delivery medical device in the OR is in a similar way. It's also a kind of hybrid use. Yeah, so the package is only the sterile barrier. And if you treat that with ETO sterilization, then you also don't have so much problems with this hydrolyzation. Yeah. So this is something that And most of these packages are treated like that.
Okay. So thank you very much for the insights about the hybrid medical devices. It's a very, very interesting concept. I will for sure integrate that into our educational programs. But now a little bit to the personal part and to your career. Why are you so passionate about medtech, innovation, and medicine, basically? And tell us a bit about your path and how you arrived where you are now.
So yeah, it's a good question. So more or less everything just happens. Yeah. And I actually studied mechanical engineering, and I don't know, during the third or fourth semester, I said, okay, I definitely don't want to build cars. And where I live, this is more or less a hard decision because all the car manufacturers are around, and this is one of the biggest job machine here in this region, at least when I studied. So I started to went to the lectures of the medical students. So I had the anatomy lecture and physiology and all these application lectures like surgery or whatever. And this was so interesting. So I never get a sheet or certificate for that, but it was interesting for me and a good learning. And then I could, when I did my diploma, so I'm on the age that I made a diploma, not a master thesis, I had the chance to work in a local company and to develop a system for stroke patients to keep them mobile. And this was more or less my first contact really to have to work on a real medical device. And then after a short period, anyway, in the automotive sector, I switched to medical technology, and I had a big chance to work in a big project developing new catheters. And this was so amazing because, it was part of the job to be in the hospital and to observe the doctors in their daily business and to ask stupid questions. And as an engineer, you ask stupid questions because you are not allowed to do these procedures by yourself. Yeah, so you can only observe and you can ask, why are you doing that? And there was a funny story in the urology. I observed a doctor, and he was treating a bladder cancer, and he was more or less working head over. So I said, why are you doing that? It's a weird position. And he said, I cannot rotate my device. So I would like to stand upright, but it's not possible because my device forces me to do that. And I said, okay, show me the device. We can just make a joint here and then it works. And this was one of a patent that we invent. And then, one comes to the other. And then you also come into this transfer section so that ideas should not only be generated in the clinic. You have to think on a business model or how you transfer that to a company. As a researcher, you will never put a device back into clinical routine. You need a company in between, someone who is like the legal manufacturer that brings this device on the market. And you have to convince the company.
So I get that you're currently happy that you're not in the automotive industry in Germany, but I think we can also learn from automotive because there's this concept in lean manufacturing which comes from Toyota, a car manufacturer. It's called Butsu, which basically translates to go and see for yourself, or get your boots on the ground and go to the production floor, which is basically what you're doing. You're standing in the OR and asking stupid questions. Why are you exactly doing it like that? And why are you in such an awkward pose? And then he's like, I can't do it otherwise because that device is stupid and I just live with it. And you as an engineer say that is no issue that we cannot solve. And if you wouldn't have been to an operation room and saw that procedure, you would never know that this is an issue that the customer cares about, because we always do the 10% cheaper, 10% better, 10% this, that, instead of really like fixing the problems that your customers actually have. And I think that's a very, very imperative the method to use in designing devices.
And you have to consider that in medical education, everything is like, you learn by observing your medical mentor, and you do it in the same way. You never question what they are doing. You don't think that there should be another way. And there's, this doctor who was doing this procedure, he never asked himself that this is maybe a stupid idea to work like that. He was complaining, but he was not questioning this thing. Yeah, I think the solution that we provide was so easy that this also could be from his side, but he was never questioning because it was always like that. And this is something that you see in the medic a lot.
And there's also another very good rule in life in general. If you know what something is for, then you can change it. If you do not know what something is for, you leave it where it is. Because there's just a chance that you might screw up the whole system with changing it. So if you encounter something and you think, yeah, what is this kind of handle thingy doing here? Nobody needs that. You just remove it, and then it's maybe a safety feature that causes an operation to go badly. But if you exactly know why he is like bending over like that, because you can't turn it otherwise, then you can change it. So it's like there's always a degree of mastery, and then you can, like, only the master can invent new things. If you do not know something about it, you have to learn the discipline until it's there, until you have the skills, and then you can start to change. That's what you should do. So like that is something that I see with also like the sustainable plastics. Recycled plastics are actually pretty difficult to use in medical technology. Not impossible, but difficult. And I think the companies that are predestined to be the forerunners in that are going to be those ones who already mastered plastic injection molding or extrusion or plastic technology. Because if you know that, you have all the basics. You mastered your craft, and then you can go beyond and do something that no one would ever have done. If you're starting out, it's probably a good idea to look to the left and to the right and see what everybody else is doing, because that's probably the safe bet.
But you also have to consider that always the driver behind an invention is business. Yeah, and if no one will buy your product, then it's not an invention that will end up in the market. So you're right. We have to use these challenging materials, but not only because people feel bad if they use the other materials, there should also be an advantage or benefit for them. And this also accounts for the medical devices. You know, when I come up with crazy ideas for medical devices and there are only 2 customers that like the idea, or the idea makes the device 10 times more expensive, you will not find customers that would like to buy it. So that's why you have to consider this business aspect from the beginning, and you have to include that. And I think for these recycled plastics, if you put into your pitch for the product that you not only reduce the virgin material use, but you also reduce the cost on the hospital side, for example, for waste disposal, for storage. Yeah, so a lot of storage can be saved because these amounts of waste, you have to put it somewhere until someone comes and pick it up. And so there's a full chain. And also, you know, even cleaning up the UR is a mess if you have 5 bags of waste or if you have 2 bags of waste. Someone has to carry it to the waste drop. Yeah, and this is time, this is human resources, this is also work that no one wants to do. Yeah, and we have to consider that in the full life cycle to make a convincing pitch to the users, hospitals, or healthcare units. And then I think this is something that, you know, in a full package can be convincing.
Yes. And as you said, that fits very well with what you said. My dad used to say, like, an invention is if you have something new. An innovation is when you can write invoices. And that's a very, very wise thing to go by. Only if you can sell it and you spread it to the market, then it's an innovation. Okay, let's come to the last question. What advice would you like to give to our listeners in regards to hybrid use medical devices?
I would really advise to at least include this thinking process of the whole life cycle of the product in the full design cycle and even in the first idea. So don't start to create a nice device concept without considering that this device has to end up somewhere. And I think this is something that is maybe not usual at the moment in the medical device sector, because there's no rule that force you to more or less have a good option to recycle, but this will come definitely. The regulations will change. So consider that not only as a, let's say, necessary feature, consider that as a really big benefit, as a product requirement, and that people maybe will make more excited. Yeah, and if you show that, I would already know, look, this is how this device works, and this is how you can disassemble it, and you can recycle it, or how you can reuse it.
Okay, I couldn't have said that better. It's like the summary of it is like feel-good devices are not the thing. It's like about strategic advantage with waste reduction, cost reduction. That's where you really sell it, and that perfectly fits with my definition of sustainability, because sustainability used to just mean, or like degraded into just meaning ecology, and it should mean cost, it should mean patient benefit, and it should mean ecological benefit, aka waste reduction. And those three can go together. And I think your concept is somewhere where those three pillars get together. Okay, thank you very much, Axel. Do you have a few last words?
No, it was really a pleasure to be in your podcast, and I think we have a lot of things to exchange, and I always learn something new, and it's always nice to talk to people who are in the same line and on the same direction, and let's try to change the world.
Yes. Form a better world with plastic. That's my vision. Good. So this was Dr. Axel Boese, and until the next time.
Thank you.